It's all yours, John.
Okay. All right, so I have to get the proper place. All right. So anyway, so this is really basic Paraview. And I don't think we're going to get to it today, but you know, this is volume rendering of some data from a simulation that Don did. And what you're looking at is the volume rendering of the x velocity in the, from this weird direction. You can see the arrows down here with the X, Y, and Z axes. So it's looking from a strange angle, but basically out here you have the solar wind flowing in, then the bow shock, and this is all the action in the tail here, both positive and negative from the BDFs and so forth. So anyway, what is Paraview good for? Well, it's a large suite of interactive tools for the visualization of 3D time varying data. Kareem will tell you that, you know, its Paraview is okay, but I think he prefers to use Visit, which is an equivalent set of tools, and just has a different, very different sort of way of organizing the working pipeline. So anyway,
I have a quick question.
Joe, you might want to unmute the other version of you. The one that you unmuted gives echo.
Is that better? No.
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 Maybe type your question in the chat.
Yeah, that's a very good point.
Yeah. I'd have to come out of share screen to see the chat, but you know,
I can read it to you.
Yeah.
I also mentioned too, I think between Paraview and Visit, they're each irritating in their own unique and special ways.
Oh yeah. But they have pretty much the same basic structure. It's just the way that how you put things together is organized differently in the two suites.
Yeah, it's a funny redundancy too, I guess, between like Los Alamos and Sandia versus like Livermore.
Yeah. Anyway, so we're waiting for see what the question is. You know, the basic structure, it's client server. You interact with the client, which is the Paraview program. The server handles the computation of whatever needs to be done and creates the actual object that the client then visualizes to the screen. If you're not doing an MPI, you basically don't see either you don't see the client, the server end of things. You can handle MPI decomposition more or less automatically. And it's a pipeline model for data handling. The data is brought in two ways, either from data files or by using what Paraview calls a source. And then you work on it by applying filters. You'll see a bunch of filters as we go on. Okay, this is just a bunch of resources if you actually want to get into using Paraview. There's the anything that's underlined is an actual link. And I guess if we put the Keynote or PowerPoint up on the the website, then you'll be able to link on this. Otherwise, you know, I can just put the links up separately. In any event, you know, there's a home page, there's a user guide, there's quite a large, quite a long online guide, which also you can find a PDF version of that I put up on Cheyenne down in the HAO project space. There's also a quick and dirty starting guide. Paraview wiki, you'll probably, if you get into Paraview, you'll find that you go down there to find discussions of various topics that are frustrating you. There are all kinds of tutorials. There's a very lengthy PDF form tutorial that has exercises for actually getting to work with Paraview. There's a very long presentation from, it was given at Supercomputing 2016, and it's, I think, probably more goes into topics that we're probably not all that interested in, but they do cover some stuff that's of interest. And finally, if you're a YouTube freak, there's a series of Paraview tutorials that I came across. They're about 5 or 10 minutes in length, covering most of the basic things. I find the presentation to be a little annoying, but there is useful information. Okay, so first thing you have to do is get the data into Paraview. And basically in MAGE, we're dealing with two different types of files. Either the HDF5 files or what are known as H5 part files. H5 part is produced by Chimp and basically consists of data at discrete time steps with all of the quantities that are being output given for each particle. The good news is that Paraview recognizes H5 part data without any problem. You don't have to do any extra processing to get it into Paraview. I'm not going to cover that today. It's really pretty simple. If anybody's interested, you know, I have some scripts that we use for some scripts for saved states that people can play with. HDF5 is a little more complicated because it's not recognized natively by Paraview. So what is done for either Paraview or Visit is that you create what are known as XDMF files that explain to Paraview what's in the data. The Kaiju distribution has scripts which you can use to produce these XDMF files. They're for the single processors like Mix or Voltron, you can just use the gen xdmf.py script. For multiprocessor files, which is what you get with the MPI decomposed Gamera, you have two choices. You can have gen xdmf.py or block gen xdmf.py. Not a whole lot of difference in what you actually get to see. It's the major difference is that the block gen produces vector quantities automatically, whereas gen xdmf.py just gives you the individual components. They both operate the same way and produce XDMF files for each time step. For example, time step 1200 would be sim.001200.xmf. Okay. Should I assume that everybody knows this about how to get a interactive window on Casper?
Probably yes. If not, raise your hand.
In any event, it's here if you need it. Okay, so this is the point where I'm going to step out of the and step out of the PowerPoint, the keynote, and go.
John, while you're doing this, there's a question from Joe. I can just read it for you if you know the answer. Joe says, I've had trouble rotating 3D isosurfaces in Visit. No problem with Paraview. Is this a common issue with Visit if data files are big?
I don't know. You have any idea, Kerry?
If I recall, there's an option that's turned off by default to essentially have it not render while you're rotating, which is usually what makes it slow, that it's trying to sort of render every step as you're moving the thing around.
Mm-hmm.
You could have it instead just rotate the wireframe around, and then it will re-render when you're done. But if you don't turn that option on, yes, it can be super annoying, I think, to try to like rotate around complex surfaces.
Yeah, was it that, Joe, or was it just simply that it didn't work?
I think Joe is having a problem with his audio.
Yeah. Okay, so this is now an interactive Paraview session, just to show you what shows up on the screen. Bunch of things up here. This is where you read in the files. You can open a file or a whole set of your set of recent files. Edit has a couple of interesting things. There's settings. A couple of things that are of interest here is that you can set this one, enable auto MPI, which will, if MPI is available on whatever machine, will allow it to offload some of the work. Typically on Casper, if you have a few things going, rendering will go about 2 to 3 times faster than if you just have a single processor working on it. The other thing that's useful is to cache the geometry for animation, which, if you're doing animation, can be kind of slow if you're going through a second time. Okay, so what I have here is a typical pipeline. What I've read in is an XDMF file from one of Kareem's substorm runs. It's a single time step. We'll get to multiple time steps later. And so you read in a single time step, then a couple of things are applied, a couple of filters are applied to it. Merge blocks, which takes the multi-block nature of the Gamera output and turns it into a single block. Then we do cell point. The data comes in as cell data, that is, it's located in the center of cells and turns it into point data. The reason for doing this is basically a lot of filters don't work on cell data, but they will work on point data. So anyway, then we come down to the first real filter that we run into, which is slice, which not too, is just does what you think it would do. It takes a plane and plots the 3D data onto that plane. So right now I have a Z normal. I'm looking down from the Z direction. If I wanted to do a Y normal, I could do that. And then, of course, up here, this is the default view, so I can change it now to look from the Y direction. And you can move, you can increase the size of your thing. Typically, this is the right mouse button on a three button mouse. You can move it side to side, like so. That's the middle button. And the first button usually is just to rotate the object. There are a couple of camera settings up here. There's a 2D setting which changes the entire button structure. But now you're operating just with the direction is now fixed in the third dimension. And all you can do is now rotate about the fixed axis. 3D is where you normally do it. You can adjust the camera by clicking here. It's useful for magnetospheric data to set the center of rotation to be the Earth, and also unclick this button because if you don't, anytime you add something, you change the center of rotation. So now everything will rotate around the Earth, around the Earth. Okay, let's see. So there are a couple other things up here. This is the view button, and you can see various things are checked. We have animation checked, the color map editor is checked, information, pipeline browser properties, etc. This is the pipeline browser. When you have a filter and you click on it, the properties window will tell you what's going on in terms of the parameters that you can set for that filter and so forth. Information usually isn't too useful, but it will tell you what is there and how it's, what the ranges are for everything. Let's see, anything else that's color map editor we'll get to later, and animation. So I think that's about all we need for the moment here. And I can go back to the go back to the keynote. There are a bunch of filters, and you'll probably see, I think, all of these, pretty much all of these during the talk. Slice, as we saw, it just creates a surface plot of 3D data. It doesn't have to be a plane, although that's everybody's favorite. You can use a sphere or a cylinder. And plot the 3D data on that. There's contour, which is a little bit of a misnomer. It's in 3D, it creates an isosurface or a bunch of isosurfaces. In 2D, it ends up being a contour plot. Glyph is the all-purpose marker filter. you have all kinds of different shapes that can be used with 3D, 2D, and particle data. The arrow shape is the one that you probably end up using the most because you can visualize flow fields. Stream Chaser does the same sort of thing except that it computes and displays streamlines. There are some other filters. There's two other filters that do similar things. There's the path line, which follows the path of a particle, and then there's over time, and then there's streak line, which is equivalent to dumping dye into flow over some sort of obstacle. Plot over line is useful because you can put a line anywhere in the 3D data domain and interpolate all of the data onto the line. By default, it gets its own plot window, which almost always is not very useful because it tries to plot every variable at the same time, and the scales are just crazy. However, you can decide what exactly is going to be shown in that plot window. The plot isn't very elegant, but it does give you an idea of what's going on. You can easily output the data into a form that Python can pick up, and then you can plot it with matplot and get a good looking plot. Calculator gets a lot of work. It does very simple calculations on the data. So for example, if you have, let's say the, you want to get the temperature and you have the pressure and the density, you can have calculator just do density over pressure, pressure over density, and it gives you a temperature. Cell data to point data and point data to cell data, just what you'd think they'd say. Cell data to point data is mainly useful because a lot of filters work with cell data. Merge blocks I've sort of discussed already. We use it, or it's used with the Gamera data sets, because if you don't, when you convert cell data to point data, you get strange artifacts at the block boundaries. A couple of things that are useful to know about. One is resample to image. Gets you a uniform grid for volume rendering. In theory, Paraview will volume render on any grid. It's just if you tried it on an egg grid, it will take you longer than you have to get out a useful volume render. Once you put it onto a uniform grid, it actually goes fairly fast. Similar thing is resample to dataset, which samples the 3D data to another grid. And you'll see this when we're talking about glyph. Okay, so I have some recorded Paraview sessions. What you see here is we're going to start off, and I've just gotten a clip here, and I'm setting it up to do a box. Clip will restrict the area over which this goes. And so I'm setting up a box. It's minus 25 to minus 25 in Y. It's just a box around the Earth. And you set up one corner, and then you give it the lengths that you want. Yeah. So once you do that, you can get rid of the box, which is a good idea, and then hit apply to actually apply the filter. And lo and behold, you've now restricted the size of the data. I will have to tell you that I've edited these things because sometimes it takes a while for these filters to go into action. So now, next filter that we're going to look at is contour, which in this case is going to end up being a 3D isosurface. So we're looking at now density. That's the D up in the corner here. And I've picked a value of 0.3 and created an isosurface. And we'll rotate this a little bit to show this is actually something like, the outer part is actually something like a magnetopause, and then we have the plasma sheet in the center of the things. And yeah, the useful source is text, which went by pretty fast. So I've now picked the source and with text, and now I can annotate the Yep, so I don't type any faster. Okay, and then you can hit apply, and it appears on the screen. If you want to move it around, you can do this. So you can annotate things. And let's just move on from there. Now, glyph is also useful for showing flow vectors and other things. It's also useful if you're doing particle data, because then you can make the particles that often are too small to see. You can mark them with a bigger sphere or something like that. Here, we're going to set up the glyph filter, which is a common filter here. And we're going to use an arrow. We're going to use, you have a bunch of choices as to how you put the glyphs down. We're going to use a lot fewer this time because, okay, so I started the glyphs and they're much too big. So we're going to have to make them smaller. So no scale array means I'm not going to scale the size of the vectors by some other quantity that you can do that here. Now let me stop this for a second. Okay, you can see that if you just, oh, I'm on the wrong one. Yeah, okay. So what you can see is that if you just have them choose, you just choose points randomly, glyph doesn't do much to help you out. So what we can do then is use this resample Okay, first of all, I'm going to make a plane object from source, which has, I'm just setting up now the position of the plane, or the, the 3 points that define the plane. And nothing much happens, except I can now have a plane that doesn't do anything useful. What I need now is to change the resolution. And so I'm going to make it 50 by 50 and apply. And you can see the points now. So now resample over data set, the destination mesh is from the plane, and yeah, getting a little confusing here. All right, so now, let me go back here. Now I want to have, you can see the glyph is connected to slice, which is not where I want it. I want it to be connected to the points in the plane. So now what I do is change the input. So now it's getting it from resample, from the plane resampled. So then you're just playing around getting the arrows to be where I want them. So now I'll put all the arrows just on the points of the plane. And now you can see, and now I have a regular distribution. It can go on for, change the size. And finally, since we just do the current density as the vector on here. There, okay. So we changed it to the current density. And at this point, it's not all that interesting. So we go to the color bar, or the color map editor, change it to something a little more colorful. And then it still doesn't look too good. So what we're going to do now is we're going to use a logarithmic scale for the current density. And now we can see some stuff. So that's basically, glyph is a little complicated to use, but once you do the resampling, you can get some useful flow fields out of it. Plot over line is, first you define a line and then you take the plot over it, obviously. So first thing, we're going to set up a line that is vertical in the plus and minus z direction at minus 15 in the tail, plus and minus, let's see, what did I put? 20, yeah. So you set up the line, and then you tell it to plot the data. You can, the resolution here is 1,000 points, which is overkill, but you can okay, so this is, it's now going off and doing its thing. There, okay. So now you get this plot, which It has all kinds of stuff on it. And what we're going to end up with is just the taking things off the plot now. So, but adding the couple of components of the call is taking a couple of things off the thing, and now you just getting some components of J, and now we have to change the scale so we can actually see something. So we change the scale here to something more reasonable. We'll actually end up going, yeah. So change the scale, and things are, you can actually get some useful information out of this way. But basically, the way that you can get good quality plots, let me back up now, is by outputting the data. And so what I've done here is I'm going to output it to a file, linedata.csv, which is comma separated variables. And we'll just go ahead and do it. And it outputs the file, and you get a file that looks like this. And it's useful for doing stuff if you want to plot up, a realistic plot. It outputs all of the data that it has available. And fortunately, the first line gives you the names of all of the variables so that you can tell Python to create arrays with each of these things, and then you can put it into matplotlib or whatever, and create good quality graphs. Okay. What we've got here is I'm going to show some animation. Some of these things are actually kind of useful as opposed to, just producing movies. I have here some mixed data that I've put out. There are actually two planes that I've offset in the Z direction a little bit. The X and Y are X and Y in the ionosphere. So this one here, this is the Joule heating as a false color plot. This one is actually on top, and if I run this, the bottom one, the bottom one is the field line current up and down. And now I want to play some games with animating the opacity of this top plot. And so I have the calculator opacity as my quantity that I'm going to animate. And so it's going to run from 0 to 1. And time is 1. And what I'm going to do is ramp up and ramp down. So the opacity starts out at 0 and then goes to 1 and then comes back down. And I hit the animate button up there and it will crank through. And what you can see is that the joule heating is located in between the region 1 and region 2 currents. So this is useful in, getting a detailed idea of, how things are set up. Now, what I'm going to do is save this animation. I'm going to put it in a folder, this folder here, and I'm going to call it, I'm going to give it a field line current joule.png. So what this will now do is create the series of .png image files that can be put together into a movie. And this sort of animation, you can just say save animation, and it goes quickly enough that it doesn't really matter. And then you can turn it into a movie, which, if you have, I hope there are no epileptics out there because I think it's liable to trigger something. If you have something that's more complicated that you want to animate, you're probably going to want to use a batch process. And the way that works probably best is when you're starting out and you want to create the image or the general image that you're going to do, it's easier to start with a single XDMF time step because otherwise Paraview will want to run through the entire sequence to get to where you want it to be. So you set it up with one time step, that's this particular thing, and then you can read in the entire set at one time and switch the inputs and do a time step from there. So, I think I'm not going to just run through this very quickly. Change the input. Now I'm back at the initial state. I'm going to go to somewhere near the end, set up a scale on the color bar, and then play around with the color table, which you get by clicking on the over here on the, and so I'm just playing with colors here now. See what looks best. Okay, so we're going to, just to give you a sense for how cumbersome this can be, right now I'm at 224, and I've just told it that I want to step one step. And I have to go the better part of a minute before it updates there. So this can be very cumbersome if you want to animate something that's complicated. But you can use PV Python or PV Batch. If you're not really a Python person, there's a fairly simple way you can do this. You create a state you're happy with, you save the state. That's in the file menu. You save the state, give it a name. You disconnect from the server, that's also in the file menu. You go to the tools menu and start trace. You load the state back in, and then you click the start animation button, which you then set up with the names and image size and so forth. As soon as the progress box pops up, which we saw previously, you hit abort, which stops everything. Usually takes a little while for this to stop if it's complicated because it has to finish a step. And you stop the trace in the tools menu, you save the trace. This is now actually Python script that you can hand off to PV Python or PV Batch, and it will run the animation for, produce the pictures you need for the animation, and finally, you can use FMMPEG to create the movie with, this set of options for FMMPEG will get you something that will play on Macs, which is sometimes a problem. The PIX format and vcodec are actually needed quite often to get QuickTime to play the thing. Okay, so a few tips and tricks to finish up, I think. In 3D mode, we've already seen set the rotation, the camera rotation to center to 0 and update the update center box. You can set the projection to be, rather than being a perspective projection with a given camera position, you can set it parallel projection. Sometimes this helps to avoid parallax distortion. When a filter shows up, has a show line, sphere box, etc., once you've set things up, get rid of that by unclicking the show button. Otherwise, you can inadvertently move stuff around, and then your sphere or your line is not where you wanted it. You can use the settings in Paraview to enable auto MPI, which means that now you can use MPI on Casper, which will allow things to run faster. It helps sometimes to, instead of just running Paraview as the command, to run VGL run Paraview. It stops hardware rendering, which sometimes interacts with sometimes the virtual screen doesn't talk well with hardware rendering, so you can end up with situations where nothing shows. So if you do VGL run Paraview, you can avoid this. And this last point I already talked about. So that's pretty much the basic stuff, I guess. Paraview has a fairly, I find the interface to be fairly intuitive once you've done a little bit of playing around with the system. But you know, like any tool set, there is a learning curve. But you can do things with Paraview that are very difficult to do with Python, for example. Visit can do pretty much exactly the same stuff that Paraview does. I find the interface a little easier to use in Paraview. And I guess that's it for now.
Thank you, John. I can confess that even I learned a few tricks that I didn't know, so I'm sure other people learned a lot as well. Are there any questions for John?
So what's the easiest way for people to share tools with each other? I mean, obviously, if we write these PV Python scripts, those can be shared. But like, is there a way to export the state of a session and give it to someone else and have them start from where you left off?
Yeah, it's pretty easy. Basically, okay, this is a live screen, so I can do this. What you do when you have a state that you want, you basically say save state, and then you have the option of, you can either do it as a Python file or as a native Paraview state. But once you have the state file, that can be exported to basically anybody else. If that person's running from a different directory, when you say load state, cancel this. When you say load state, you can pick whatever you'd like. When you do that, it'll come up and say, do you want to use the file names that the original state did? So if you're working with a different set of data, or it's, you've given it to somebody else who has the file in the data file in a different place, they can modify it and just go from there. And then they can save it as either the same file, save the state as either the same state or some other name. So it's actually pretty portable in that regard.
Yeah, that's good. I mean, that's very useful for teamwork if we can share with each other.
Yeah, and with that animation method for getting the animation script that I showed, if you're a reasonable Python programmer, you can go in and take it and basically set it up so that it will take arguments.
Yeah, I have done that before. I mean, the extent of my Paraview knowledge is mostly using existing scripts that Mike Wolperger gave me.
Yeah. I haven't heard from Mike. He hasn't complained yet.
Sorry, guys, I haven't been able to participate much. I was coming from another meeting, but those scripts have got to be old.
Yeah. Yeah, I think we were, Paraview 3, maybe 2 even, back in the day.
Well, I think maybe you talked about this, but I think the big change between Paraview, whatever we're on now, 5, and what we were doing then is we had to design a custom reader. And with the Gamera files and the HDF5, you don't need any of that stuff. So it definitely it's much more portable that way because you don't have to have installed a separate reader code that you wrote.
Well, as Kareem and I can attest, initially figuring out how to use XDMF was a struggle.
Oh, it's baffling. XDMF is completely mysterious.
There is actually a web page now with some documentation, but basically back when we started, you had to take some XDMF code and look at it and say, I guess if I do this, maybe this will happen. It was ridiculous. Anyway.
Apparently I wasn't the only one to struggle with that.
No.
So another format that both Paraview and Visit will read easily is VTK. And in fact, Paraview is, as far as I understand, is just a GUI interface around VTK library. Everything that is doing underneath is VTK.
Yeah, it's.
But Visit is not Visit. That doesn't apply to Visit. Visit is completely different. So oftentimes, for instance, when I have data in some format that I don't know how to import into Paraview or Visit, I write simple Python script that will create a VTK file.
Mm-hmm.
Yeah, I do that too.
Any other questions for John? I guess if not, we will thank John again for the excellent tutorial. It's been recorded, so we'll post it online somewhere, and people can watch it on their own time.
Yeah. Okay.
Okay. Thanks very much, John. Again.
Yeah. No problem.
Take care, everyone.
Thanks.
Thanks,
Thank
John.
you.
Bye.